how do we describe a data set? In Chapter 6, what we're learning about is how to take a set of quantitative data and describe it in different ways, analyze it, pull out as much information as we can. And that starts with Section A, which is about characterizing data. So the first thing that you might think about in describing a data set, so you have a collection of numbers, a collection of values. What can you do to summarize it? Well, you could take the average, all right? So the way to start thinking about things is that the quantitative data from a sample is spread out in a distribution, so you have a whole range of values. One of the main tools that we'll use is called a histogram. So we can take the distribution of values, take that collection of values, and plot it as a histogram. So we'll show you how to make a histogram in the examples. There's a, let me quickly swap over to the example worksheet. So the first question on the example worksheet has a histogram on it, and in the video you see how to make a histogram. So how we plot that out. Now, on any distribution, or for any distribution, there is a measure of the center. And it's sort of a vague term, but it's intentionally vague. It's what do you mean by the middle, the kind of typical, the common value? There's different ways to quantify what we mean by that. And the three that we'll refer to are the mean, the median, and the mode. I imagine those terms are familiar to a lot of you. The mean, you're summing over all of the values and then dividing by the total sample. So sample size will be an important term going forward. The formula for the mean is down here. I use the symbol with a bar over it, putting a bar over the variable to indicate that it's an average. That may be common for some of you, maybe less common for others, or some of you haven't seen that before. But a fairly standard thing is that a bar over a symbol means the average of that value. So this means the average of x, or the mean of x. This symbol is the mathematical symbol for a sum. So sum up all of the individual values, divide by the total sample size, which I will always call little n for total sample size, the number of things in the sample. Okay, so we have an example here that we're going to look at in more detail in the next couple slides. The number of films in a popular science fiction series, this could be the data set. So for each title or series, there are a number of films in that series. So this is the data set. And for that data set, you could describe the average number of films in a science fiction series. Or there's other ways to describe what the center is, and we'll get into why you might choose one or the other. The median is just the middle value of the data, and the mode is the most often occurring value in the data. All right, so in this data set, the things on the left, those are the subjects. So tying this back to the language from Chapter 5, these are the subjects of the study. Each of these series is its own subject. The quantitative information we're getting describes this subject, right? So you can think of this as a person and this is their height, right? This is the series and this is their number of films. So this is the number of films is the variable that we're studying, and this is the data for that variable. And the center of that data could be described in more than one way, the mean, the median, or the mode. And context of the example usually tells us which one is better. So let's calculate them for this data set. The mean is you add up all the number of films for each series, and there are 5 series that we're looking at here. So that's the sample size. Add them up, divide by 5, you get 8. So you get a mean of 8. The mode is the most often occurring number. There's a small number of series here to look at, so there's only one that occurs multiple times, and that's 8. And so the mode is 8. And it turns out that the median also happens to be 8. So we've lined them up in order 5, 6, 8, 8, 13. So cross out the max, cross out the next one, you're left with 8 in the middle. And so in this case, it happens that they all have the same exact value. The mean, the median, and the mode are all the same. So it doesn't really make a difference here, whichever one you choose to describe the center of this data set. Now, what often happens in data sets is there are outliers. We have covered this a little bit before, but formally, an outlier is a data point that's much higher or much lower than almost all the other values. And a value like that can have a substantial effect on the mean. I usually think of it as it pulls the mean to its side. It's almost like from a physics perspective, it's like leverage, right? So imagine you have a teeter-totter and you sit on the end of that teeter-totter. It's really going to have an effect on the balance. An outlier acts like that. It's like a heavy thing set far away from a point of leverage. That's its effect on the mean, but it doesn't affect the median or the mode very much, because you can put a high value, and it's the value that doesn't matter in calculating the mean. It's only the middle value that matters, right? So it doesn't matter, the numerical value of an outlier doesn't make a difference to what the median is. It just shifts it by one place left or right. And similarly with the mode. Outliers are necessarily things that are not occurring a lot in the data set. There's kind of unique points, so they're not going to factor into the mode. All right, a pretty easy example to see the effect of an outlier on the average is, say I said, what's the net worth of everybody in the class? And then just by happenstance, Jeff Bezos, CEO of Amazon, he walks in and sits down. I got to include him in the total. Well, he's worth $112 billion. So now, on average, everyone in the class is a billionaire. Obviously, that's not any sort of useful information to have, right? It in no way characterizes our data set correctly. It's just that the outlier has skewed the average a lot. So what can you do when you have outliers in your data set? Well, you can use the median instead of the mean. You can ignore it and remove it from the data set. You have to be careful about that, because throwing away data is usually not a good idea. But sometimes a way to compromise that is you can find the mean both with the outlier included and without it included. And that's a way to sort of give two answers to the question, right? So the average without the outlier is this, the average with the outlier is that, and maybe there's an argument to make about why one is more representative or another. Okay. Now, so far we're talking about like one number, the measure of the center. But I started out by saying it's a distribution. We have a histogram that describes the distribution of the data, and that can have a shape to it. And we can characterize the shape in a number of ways: by counting the modes, by its symmetry or skewness, by the amount of variation in it. And we're going to get into a variation in more detail in the next lecture that is focused on the study of variation within a data set. But for now, we're thinking about the shape in general. So you plot a histogram, and you'll see the shape right away. And that has a lot to say about what the data is showing. Okay, so here's our example. A teacher can plot a histogram showing the number of grades in the 60s, 70s, 80s, and 90s. So let me think about a couple of different scenarios. Maybe it's a really, really easy exam, so everybody gets in the 90s. And then your histogram is just essentially one big bump with all the grades in the 90s and then nothing over here. You could have a very, very challenging exam, and there's lots of grades in the 60s and the 70s and nothing over in the 80s and 90s. Or maybe you could have a somewhat more fair exam where some people do really well, some people do poorly, and the middle is somewhere in like the 70s, 80s range. And in that case, the histogram has kind of a bell curve shape. Okay, so let's look at some different shapes of histograms. Uh, Talking about the number of peaks, we have unimodal or bimodal, or there could be trimodal and beyond, right? You could have more peaks in the data. Those are usually saying something interesting. So for height, for example, it tends to be unimodal. Average people are somewhere in the middle, and they're more common than people who are very tall and people who are very short. But then other distributions are bimodal, like this one, weekday traffic, right? You have a morning commute and an evening commute, and so the amount of traffic, the number of people traveling, peaks twice a day. So it's a bimodal distribution. We can talk about symmetry or skewness in a particular direction. So this would be a symmetric, perfectly symmetric, but in all three of these top cases, but the distribution's different, right? This is trimodal, has three peaks. These are both unimodal, but the shape is very different. So what is the shape telling us? What information does that shape carry about the variable we're studying? Or it can be skewed one way. So this is symmetric again. In the symmetric case, mode equals mean equals median. The most common value is the same as the average value, which is the same as the middle value. But when you have skew, these numbers are different, right? So if there's any sort of skew, it gets pulled one way or the other. The peak does. The peak is always the mode, but the mean and the median are drifting to the side. So notice with a left skewed, the tail is on the left. With a right skewed, the tail is on the right. These values over here are outliers. Okay. The mean is pulled more than the median, and that's why when we have skew in the data set, the median tends to be a better, more representative value to talk about because it's not as affected by the outliers as the mean. Okay, and on to the last slide. How widely is the histogram spread out from the center? So we talked about the number of peaks, whether it's skewed or symmetric, and then the last thing, which actually leads us into the next lecture, is how far is it spread out? Is there low variation, meaning that people rarely get values over here, people or things, whatever the subjects are, don't get values over here very often at all, if at all. Moderate, where there's a peak and it's spread out to a moderate degree, or high variation, where there's a big range in possible values and you're pretty likely to get a value on the very low end or the very high end. And the peak in the middle is not as strong, it's not as tall. Okay, so I don't want to say anything more about this for right now. I'll leave it to the next lecture. But that in a nutshell is how you characterize data. We have these three quantities that we're using, mean, median, and mode. And they describe the center, quote unquote, center of a distribution, which can have different shape qualities. It can have multiple peaks, it can have a single peak, and it can be skewed, and it can have different types of variation.